All right, we're in, and we're doing question. What was it again?
This first one's question 8.
Question 8. Okay. Find the area, first quadrant. Okay. Now, first off, this is a homework problem. Do you mind me going to Desmos graphing for a minute? You're okay with that? I mean, I could like make a table, and try to figure out what it looks like. But I'm thinking this looks like a petal, like a leaf petal. That's my first thoughts there. So let's just see. Desmos graphing. So 10, 2 minus cosine 2 theta, and then all of that to the 1/2. Oh, well, not a leaf petal. Gosh, man, that's kind of weird. It's like it wants to be a peanut. Okay, so if I made it like a 1.5, oh, okay, 1.2. Now it's a peanut. Anyways, so we got like a peanut, and they're wanting the area in the first quadrant by this thing. So it's like this, like almost triangular looking shape, right? Peanut time. Find the area. Okay. Did you want me to keep cheating, or do you want me to do it by hand? Let's keep cheating, and then we'll do it by hand. Okay. So integral, and what are my limits? Do you think for first quadrant?
0 to pi over 2.
Perfect, perfect. And then integral from 0 to this business here. That's not, it's a 1/2 of r dr d theta. We got an answer. It's probably in terms of pi. So if I did a divide by pi, then it might be like a square root something. Okay. And it says exact answer. Gosh. Okay, well I tried. Let's go ahead and do real math now. It's worth an attempt though, isn't it? Do y'all at least try stuff like that on the homework? Sometimes? No? You just know it's gonna be bad. If you say so. Are y'all okay with how I'm setting up the limits? R, dr, d theta? I mean, it was your question, James. I just want to make sure.
And I figure out what I did wrong.
Already?
Yeah.
Oh.
You know when you kind of have a stupid moment when it's like midnight and then you don't quite read things how you're supposed to?
Okay. Sure.
I realize that.
So this will be 1/2 r squared from 0 to all this stuff, but it's a but whenever I plug that into r squared, it looks a lot prettier. We got 100, and then that square root just goes away. So we're left with this guy instead. 0 to pi over 2. The 100 could come out, so we have a 50 in the front. But when I integrate this, I'm going to integrate it. Yeah, I will. I'm going to integrate it. The 2 gets a theta. Sine of 2 theta. Sine goes to integration. So negative sine. Yeah, it'll go to, I did positive cosine?
Yes.
But again, I have to be careful because of U substitution stuff. I believe I'm going to divide by the 2 positive cosine 2 theta from 0 to pi over 2, I think. Let's toss it in and hope for the best. So I did skip a little bit of steps right there. Cosine at pi is -1. So -1/2. And then plugging in the 0, that goes to 0. Cosine of 0 is a 1. So we actually just get a 1/2. I think what's going to happen, like when you distribute, these 50s are going to combine. And so I get a 50 pi, and then because it'll be 50 divided by 2 and another 50 divided by 2, it's like 25 and 25 make a 50. So that's my guess. Now, what I'm going to do real quick is I'm just going to, oh, look at that. Good. That's a good sign. Here we go. Cool. So, good?
Yes, sir.
Better?
Yes, sir.
Best? I know. Yeah. Okay. Good, though? Good? Good? Give me another one.
So this question has a very specific problem that I ran into. So it's question 11. I don't know if it'll be the same question. Yeah,
That's it?
it's very similar.
Is that the one that does the same answer all the time? You messaged me about something.
No, that was a different question. I don't remember which one that was. I only wrote down these two.
Cardioid is a heart shape. It's not a pedal. I just want to tell you that because I messed up. So yeah, cardioid is a heart shape, and I'm gonna just draw these two right quick. I'm not gonna use Desmos graphing. I know we can do this without it. So we got 1 minus sine, 1 minus cosine. And so the 1 minus sine is a y, but like the tip is going into the negative, I believe. Okay, I will use some Desmos here in a second. So that's my sine. My cosine, the tip is going into the negative. So I think it's actually going to do this here. So that's my cosine. This is my sine. And was it first quadrant? The common interiors. What? Okay, I'm going to definitely graph it. Sorry, I'm going to graph it. I thought I could probably do this without it. Just to make sure, Oh, look. Oh, I was right at least. But having this like overlapping will help me a little bit more. Okay. You see how when you do it, it's only the stuff in this quadrant down here. You see, that's the thing that I didn't quite know. Are they overlapped? Look. Oh no. Look. That little dude is going to be mean to us.
That's what I ran into last time. Like,
It looks kind of like I don't know, like a berry of some kind, maybe like an apple. It's kind of weird at the bottom. I don't know. So there is a tiny bit of quadrant 1 that we have to look out for as well. So what I want to do is find out where they're intersecting here, and then where they're and all this stuff here, and then where are they intersecting down here. So they're intersecting there. Well, we can tell that it's at 45 degrees. So maybe that's going to help us find where that point is, like how much radius I have. What if I plug a 45 degrees in right there? Right. Yep. Yeah, exactly. Square root 2/2, and then we can do some math with it. It's just like you're doing all the scribbles there, Chad. Stop it. Yay! That should be like, I guess, how far out it goes. I don't think I'm going to use that though. I just think I'm going to use the 45 degrees. Okay. Well, here we go. I'm going to do 2 different integrals because it looks like it's 2 different zones in a way. So let's do the tiny one. I'm going to guess that it's from 0 to 45 degrees. Hopefully. You know what? I don't like this. I don't like this at all. This is not good. Because what happens, let me zoom in and show you. I'm going to go from 0 out to this black line here. And then I have to say plus, and then I have 0 out to this purple line. Oh, well, they're symmetric, though. I could double it. So let's go with that. I'm going to say from 0 to pi over 4, and then I'm going to double it. And then that'll be the tiny area. So double it. 0, pi over 4. I'm going from 0 to the black one is my cosine. R dr d theta. R squared over 2 cancels with the 2 right there. So we get an R squared. 0 to this stuff. Toss that dude in. So then we get 1 minus cosine all squared from 0 to pi over 4. I wish I had a calculator at this point. On the exam. But that's okay. I don't think U sub is going to be helpful here. I think I have to do it like this, which is kind of gross. Would you agree that it's gross? Okay, as long as we're in agreement. Negative cosine will go to...
Negative sign.
It is negative sign. You're right. And then this cosine squared is actually a formula, which I remember because I just did it a second ago before class. How nice of that. How convenient. And this is double, so this should be this little zone right here. So pi over 4. When I plug that in here, I get square root 2 over 2. So, yep. Hit this guy, I get pi over 8. And then here, I'm going to get square root 2 over 2, square root 2 over 2. So it's like 2 over 4, which would be a half. That's kind of weird. Plugging in a 0, 0, sine of 0, 0, that goes to 0, this goes to 0, so that's all we got. Okay. So this is 2 over 8 plus 1 over 8 makes, this is supposed to be equal sign, 3 over 8 pi. And then I have a plus 1/2, and then I have a minus square root 2. Lovely. That's only 1/2 of it. Yay. I can't even draw a 2. Okay, so that's my zone for up there. Do they split it up? Can I say no? Okay. Now for this big berry part. Again, it's symmetric. I think if I go from what angle would be down here? Sure. 5 pi over 4, and then it goes until 2 pi, and then I can double that. So of the black one again. So I basically have the same thing. So let me see if I can find some commonalities. That way I don't have to do the whole problem over again. It seems like I'm taking this from 5 pi over 4 to 2 pi. But if you look, doesn't it look the same? Except for these last little limits? So what I could do is I could just take right here at this point and just plug them in. Like I even had the 2 is the same. So everything should be the same. I'm just taking this and plugging in 2 pi, etc., etc. So 2 pi, I'm looking right here. That would be a 0 at 2 pi. 2 pi, and that would be a 0 at 2 pi minus, plugging in now 5 pi over 4. 5 pi over 4. That would be a square root 2 over 2, but negative. Very good. So then the 2's cancel. Plugging it in here, I would get a 5 pi over 4 again. And then this would be square root 2 over 2, square root 2 over 2, and they're all negative, but the 2 negatives make a positive, so it's actually the same as what we had last time there. Just 1/2. Okay. Whew. At least we didn't have to integrate twice. Yay, Chad. Not a lot of enthusiasm there. I get it. And then we got 5 pi over 8, and then 1/2 and 1/2 will make a quarter minus a 1/4. It says exact answers, right? So could I just not simplify? Like these guys will combine together. So I'd have an 8 would be a 10 minus that, so that'd be 15 pi over 8. I have a minus 1/4 and a minus square root of 2. So it's like I want this one and this one together. I don't know why you're writing it down. It's probably wrong. So, like, yeah. Let me zoom out and let me do this. Okay, here we go. Okay, so I'm adding these together. There's no way this will work. This is just insane. But I mean, on an off chance, 3 pi. I don't feel like I did anything wrong. Okay. Well, yeah, like, duh. Yeah.
Funny thing is too, so when you do the help, like not help me solve this, but like the example is it shows one that basically where it's like just two petals, and it's like, oh, just find the area of this. It's like that's not, but dealing with.
So these are good. And then if I mush all my pies together, so I have to have this one, and this one. Let me see what we get with our pies. I'm gonna go to Desmos for this. So we have a 3. I minus the 15 over 8, and we have a plus 3 over 8. So 3 halves. So basically I've got 3 pi over 2 minus 2 square root of 2, and then I had this dude and this dude. But let's go see what's going on. Oh, look. So the only thing that I'm wrong about is this constant term. And so if this was a half, then they would cancel. If this was a fourth, then they would cancel. So either it's this number or it's this number that's wrong. But like, as in, we're really close, okay? That's pretty good for this nuts problem. So this one looks like a fourth because I had distributed, right? And so to get the half, I had plugged in these guys. Oh, yeah. Look. This is what I didn't do. I had said it was a half, but I forgot to put this half in the front of it. So this was technically the 4, and then those two canceled. There it is. We were really, really close, okay? Really close. But see how I also work backwards so I know what I did wrong? Yeah. Good?
Yes, sir.
Do you have more for me? Are you torturing me today?
I think that's it. Other than that one problem, but I don't remember where it was at.
Well, you find it again, I'll do
Yeah.
it.
I'll come with it Monday.
Sure. Do y'all have any homework questions? No? This isn't due for a bit, is it?
The 14th.
Yeah, so we got time. Yeah. We're almost done with the work here. Oh, don't look at that. So I was doing it all before class for once. So that's good. Hey, yeah, 2 problems took 30 minutes, so we're great. Almost 30 minutes, 25. I got this one correct this morning, so that's a pretty cool thing. After, of course, I got it wrong 3 times, and James had to look at it with me. But eventually I got it right. So let's do this one here. Cylindrical coordinates. Really, there's nothing new here because they already gave it to us. I mean, we can go back and say, oh, what about cylindrical coordinates? It doesn't matter. Just do the integral, right? So Desmos, and you're done. Okay. It's not a joke here, Chad, because you're just teasing me now. When I integrate in terms of z, what would I get right there? Integrate in terms of z. We get r and z together. Yeah. I had put r squared over 2, and that was wrong. I was doing the wrong integrals at the wrong time. So yeah, watch out for that little stuff, you know. And of course, I'm going to plug them both in the z. So square root and I got a regular. And I am going to distribute that as well, because we're going to have to do two separate types of integrals here in a second. Okay, there we go. Cool, let's pause. So now I need to do an integral in terms of r. What do I do with that square root? U sub. Yep. Did you know that just because we were looking at it this morning?
I actually got a little bit farther ahead, and that's.
Oh. Yeah. Oops, that's not it there. Thank you, I guess.
Sure.
And I always go one step further. I solve for like the dr essentially, so that I can just plug it in. The other side's super easy. Oh, I already got an equal sign. So on this side, I have r square root of u du over negative 2r, and then I've got r squared dr. There's a d theta, but whatever. These r's cancel. So I have this 1/2 in the front, and my integral of square root of u Yep, 2/3, because this now turns to a 3/2, right? Because it's technically 1/2, and you add 1 to it. But that's still not good to keep it a u. We need to like convert it back, and those 2's here cancel. So I got negative 1/3, 2 minus r squared to the 3/2 minus 1/3 r cubed, and now from what, 0 to 1? Okay, well, that's easy. Okay. In fact, I'm now gonna skip down over here since we're gonna start working down there now. When I plug in the 1 everywhere, so I got integral still. I still have to do that last integral here in a second. When I plug in a 1, I get 2 minus 1 is 1. 1 to the 3/2 is 1. So essentially I just got 1/3. And then I plug a 1 over here, and I get negative 1/3 again. When I plug a 0 in, I get a 2. So that looks a little weird. Again, it's 2 negatives make a positive. So I got a 1/3, 2 to the 3/2, and we'll figure that out here in a second. And then plug in a 0, we get a 0. So that would be plus 0 essentially. Okay. Well, this is just going to be a number, right? Whatever it is, just a weird number. But there's no thetas. So when I integrate with a theta, yep, just a theta. And I plug in the pi and the 0, just get a pi out of it. So I just do a pi in the front. These two here together make a negative 2/3. And this guy here would make 2 square root of 2 over 3, essentially. Like I'm trying to like just make it look a little bit more pretty. And now I'm factoring out what they have in common. They both have a 2/3 essentially. The 2 on the top and a 3 in the bottom. Leaving behind a 1 and a square root of 2. I think. Real quick, flash the answer, make sure I got it. Not that one, don't look there. Yes. Square root 2 and a 1. Yep. Okay, cool. We did it! We did it right! We need to have more you-dos. Board work? Weren't you suggesting board work? Like at the...
That was late. Oh, you said the other day, you're like, oh man, I thought we'd have more board work.
Did you want more board work? Oh. Because you already have to write your own notes. Like, this would just be a waste. Yeah. It's funny. Anyways, is that one okay? It's pretty straightforward because it's already given to us. which is nice. Unless y'all need me to hang around. Good. You're still copying. I'll wait. I don't mind waiting. I'm a good waiter. In that way too, I guess. I used to be a busboy at Texas Roadhouse. Didn't last too long. They didn't like me. Yeah. No. Well, okay. The rolls at the end, you're allowed to have the rolls that are left over, which there's like always a lot of rolls left over. And so, like, yeah, I would just take like rolls, man, dozens, literally dozens, and throw them in my face while I'm eating. And of course, like the bus boys are like doing the nasty work, so it's like grubby hands and
Wait, did you not wash your hands after?
no, man, you just gotta keep going. You ain't got time for that. It was pretty gross. Yeah, but I really wanted to be a dishwasher. I envied them, those guys in the back. They were so cool, and they did such cool things. And then I'd do some dishwashing, and they'd say, "Chad, get back out on the floor." And I'm just like, "I'm sorry." I'm drenched wet and stuff, trying to do stuff. And back in the day, I'm just trying to stall because I don't want to do this one. It is kind of weird looking. I think that if I take my time, I can get it. Did y'all want to do this one first? You do? You do? Okay, go ahead. I'll wait for a minute or 10. Yeah, it's more like a 30-minute problem. Here, while y'all do that, I'm going to work on it over here. Don't look at the answer. Because, like, what I did was wrong, so. And if you ever do get it wrong, it's okay to just, like, you look at it. If you can't figure it out, just kind of erase and start over. It's okay. Okay. I just don't like the order of operations here, the order of integration. I'll keep it. I'm just always scared with cosine squared. And it's like, it's just a formula, Chad. Oh, that might be where I messed up last time. Yeah, it got super quiet in here suddenly. Yeah. I'll explain all that, like for the folks at home and y'all for real. I'll explain all this here in a little bit. I'm just playing around myself, you know. Okay, that's good there. Oh, I see where I messed up over there too. Okay. Oh, no. No, I was definitely... Okay, my bad. Why do I have an R there? It's a Z. You're already done?
Almost. I need a calculator.
Gosh.
I have no idea if I'm right or not, but we'll find out.
You're the only one laughing. No. I'm playing with you, bro. Like, gosh. Of course, now Mason's not saying nothing either down over there. Oh, you're just resting. That's it. You're only halfway done. You gave up. That's... No? All right. So I'm a slowpoke. That's what's going on. That's fine. That's fine. Okay, I'm getting answers very similar to what I got the first time, which already scares me a lot. No, that would be it then. Yeah. Is it calculator time? Let me check this out. Come on now. Show me something good. Ah! Again! Okay, hold on. And then... at the beginning. Oh. So that's a single 1R. Oh. What did I do wrong? Yeah. No, I'm going from a 3 to a 4. So I'd have a 4 in the bottom. Anyways, I messed it up already the last time, and I got something different. Yeah. Oh, it's right there.
Oh, I think I got that one.
You did?
Yeah.
Y'all are better than me.
The different step you took is you went straight into the integrating that instead of doing the sine times cosine. I instead left it as the double, I left it as cosine 2 theta, then integrate, so it would go from like 1/2 to 1/4 sine 2 theta.
I mean, that should be equivalent, though, in the end.
I'm saying that's the difference between yours and mine.
And it could be off by like a whole number down here somewhere. And
well, yours is really close to what I got in the parentheses.
Oh, really?
27 over 12 plus 81 over 4.
Okay. Oh, well, yeah, but my 2's are going to cancel that. Then I would have gotten what you got. Did I type it in wrong then?
You did type it in wrong. You forgot to distribute the 2 into the 24, which would cancel that out and make it a 12 instead of the 24.
Right, but that's the point, though. Go ahead. No way. Oh! Oh, okay. Look, guys. Obviously, I have crazy dyslexia. So,
You want to know what I hear? Since you got it wrong, you'll be a little bit.
well, yeah. No, well, I always am, and that's the stuff that I look for. When you write this stuff down on the blue book, I can see what's going on, and even if, let's just say, even if I miss it, then you can always argue back because you would look at the blue book and say, look, where did I go wrong, and we can, cuss and discuss is a phrase you can say. Okay, well, anyways, we got it. Let's talk about it. I mean, unless you don't want to talk about it, like nightmares and stuff. You don't want to? Oh.
This problem I think is probably like one of the easier ones I've
Really?
so far. Yeah,
Right.
you get rid of any like variables like with data, you throw like cosine, so that kind of just goes away at the beginning. The most difficult portion of it is cosine squared.
Right.
Yeah.
Oh yeah.
Yeah, I actually took a guess I got it right. I had to look at Chad's. I kind of just.
You're right. The cosine squared for sure. So like, yeah, I distributed cosine squared, and then this one had to get a theta. That was like those little things can throw you off, you know. Plugging in the pi over 2, we get the pi over 2. This will always go to a 0 there, and then a pi over 2 right there. 0 make everything go to 0. So I started canceling things out, simplified a little bit, and that's when I started to integrate. So 3, this is actually 2 times 4 to make that 8 down there. And then here I got the r squared over 2, essentially. I just did that part. Plugging it in, you get like a square, right? Because it's half of 4 is 2. And then here I had a z, but then z and 2 more z's make 3 z's total. And then after that, I don't know what. Oh, I just integrated again. So then, yeah, 3 over 3, 4 over 4. Make sure you type it correctly. Thank you for spotting that. I was just about to go back through the whole problem, but it was all right there at the end. Ugh. Okay.
I made a mistake and I still got the right answer.
Really?
Yeah.
Okay.
It wasn't a major mistake. It still all canceled out the exact same. But I'm like, oh, yeah, that's not supposed to be like that.
Good. Okay, that makes one of us then. Cool. Should I move on? Okay. Cool. Let's
See if we can knock out this next problem.
Oh no. Oh yeah, let's not look at the answer.
Yeah.
It looks like a little moon shape. Little moon shape there. Are we only getting just what the limits are?
Yeah.
So let me check back. That's it. They just want to say set it up. Okay. I think we can do the setup. I don't want to have to integrate this thing. So looking at it 2D version, you can see they have x is positive this way, and then we have a y. So we have 2 little moons that I think are like this, and then like this. And again, I'm doing positive x because right here is positive x, positive x. So it's this shape right here we're looking at. That's the most important aspect. The z should be easy because it's just going up to a positive z equals 36. So I'm just going to make super huge integrals here. R dz dr d theta. Because that's how they set it up? Yeah, okay. Because we can't change their limits. If they said dz dr d theta, then it's dz dr d theta. And this is going to be a z equals, an r equals, and then finally a theta. Okay, here we go. Z, where are we starting down here?
I assume 0.
Going until?
36.
Done. I love when we get a third of it correct without doing any real math. The theta part's interesting too. We have our 2 r's, and I'm going to figure that out in a minute, but I want to know what kind of thetas we're talking about. In order to do that, I'm going to set my r's equal to one another. So I'm going to say 9 is equal to 9 plus 9 cosine theta. What do they all have in common? Therefore, I can cancel them and make a 1 in their place. And I move the 1 over. Now I'm going to get a 0. So when is cosine equal to 0? Perfect, perfect. Yep. Perfect, perfect, perfect. Yep. That would be straight up and straight down, essentially. And that makes sense right here and here, where they're touching one another. So I want to say then pi over 2 to 3 pi over 2. Well, what that would do is this side, and that's not what we want. So how could I write it correctly? There you go. It's negative pi over 2 to pi over 2 to keep it in quadrant 4 and 1. And now we just need to know which one is further and which one's closer. And I do say like bottom and top, but when it's coming to like polar form, I'm saying closer and further from the origin, from the radius, I guess. So which one would be the closer one? 9, and then the further.
So 9 plus 9 cosine theta. And the one funny thing about that is that you can kind of figure out which goes where by the boxes they give you.
Well, yeah. Oh, that's on the workbook.
Yeah.
Amanda like erased it for me. So that's why I have, yeah, it's literally the same copy paste. She just put little boxes on top and erased it for me. Yeah, okay.
I noticed that, like, I wonder which one goes where.
That's funny, actually. Yeah, I told her to make it so that you can't tell, especially in multiple choice. But she did pretty good, I think.
And plus, it's kind of, this one's a little bit easier to kind of know which one goes where, because the cosine's always going to be slightly more or equal to the 9, so therefore it'd go on top.
Right. Phew, I don't have to integrate it. That's good. Good times there. Mm-hmm. Yep. It is the first revision. Well, we got 15 minutes. Can't get rid of it. We got to keep going.
Yeah.
And they already gave it to us. We just got to do it. So, spherical. Now, again, spherical's a little odd because we have this as required, right? It's a little bit more than polar form stuff, but it's still just going to be do it, right? So we're starting with rho, and so I'm going to integrate this guy. You can already tell what's going to happen there. What do we get?
We get 1/3 rho cube.
Yeah. Sine phi from 0 to garbage all over 2. D phi, d theta. I'm going to switch my colors now. Okay. So yeah, that one's not too bad, at least to start with. And then of course, plugging it in technically isn't that bad. Let me put the 1/3 in the front, so I don't like get it mixed up there. Again, I said technically not bad because we're just plugging it in.
Could we factor out 1/8 just to kind of give us?
Oh, that's a good idea too. You're right, because there's a 2 cubed is 8. 8 and 3 makes a 24 in the front. Okay, that looks a lot better too. Thank you. D phi d theta. Now this actually is much easier than it looks on the surface. Like what we're going to do now is actually not too bad. U sub, U is equal to 1 minus the cosine. So then my derivative, be careful here, my derivative of negative cosine is, yes, positive sine. Very good. D phi. And notice, don't we have that? Look at that. So normally I go to the next step and divide, but we already got it, so I could just plug it right in. Yeah, that's going to be fine. So then I've got u cubed du d theta. So much easier. And so then I got u to the 4th divided by 4, but I already know what u is. I'm just going to go ahead and plug it in. So 1 minus cosine phi to the 4th all over 4 from pi to 2 pi. That's a very weird fee. That's a very strange fee. We don't normally. I have never seen that. That's strange. Okay, I'm going to start working down right here. But nevertheless, we can plug them in. Oh, and the 4 can come out to the front, right? So 4 and 24 makes 96. So when I plug in a 2 pi into phi, so cosine of 2 pi is 1. 1 minus 1 is 0. So I actually get a 0. It's kind of weird. When I plug in the pi, I get a negative 1. And so that would be 2 negatives make a positive 2. 2 to the 4th is 16. But I think it's a minus 16. I'm getting really nervous. It should be a negative because this is not supposed to happen. Pi to 2 pi does not make sense. I am guaranteeing a negative. Guarantee is a great word for right now, right? Yeah. Good work there, Chad. Good work. This one's actually at the very end super easy, right? Because it says do your theta. I don't have any thetas. And so what do I do with this thing? Yep. Can I reduce that down to make it look pretty? Pretty. Look at that. Now, that's not a volume, but they didn't say it was a volume. They just said triple integral. I'm going to flash the answer right quick. Boom! Got something right for once. Cool. Yeah, this phi here, 2 pi to pi kind of thing, that makes no sense. It's like backwards. It should just be 0 to pi. I don't know why they did that. But fine. You just get a negative. So whatever. Is that okay? Yeah? That wasn't too bad.
It looks worse than it actually is.
Right. And it can be worse than it actually. But yeah. This time not too bad. Making sure. Hey Lee, who gave you that calculator? Exactly, right? Because someone took physics and then. Do you have to do you have physics or something? Oh, what class do you use that in? This one? Oh, good job. Yeah, very good selection. Sorry, I'm sorry. I actually hate that calculator. Yeah, I do. I can't stand it, but I can't. We have to use it. It's the one that we have. I'd rather much have the Casio. Yeah, the Casio is way better, but I can't say that. Oh, I just did. So what we got 5 minutes. We have enough time to at least do the top part. I think that the top part's not going to be too bad at all. They even gave me a 0 down here, so that's kind of nice of them. Rho squared sine phi. So when we do integrate, this is pretty much just a volume because there's no variable density. It's kind of like saying 1 right there. Okay, so we're looking for rows. We're looking for phis. I see a row, and if you're looking right here, it looks like there's this between the sphere. Oh, okay. So there's it's like a big bubble sphere, and then there's like a little bubble sphere kind of thing. They're wanting all the stuff inside. So then what would be closer? Do you notice the picture? Which one would be closer to you? Okay, looking right here, which one has the smaller radius? The 7. Like this changes a little, but ultimately it's still a radius of 7, right? So 7 cosine of phi, and then all the way to 10. As far as what phi is concerned, note that we're going from positive z downwards. But how much angle did we go down? Or we can say from here, how much angle did we go down? How much is this right here? Pi over 2. Exactly. It's pi over 2. So we're going down 0 to pi over 2. I guess the words got in my way there. And then theta, they're saying now, I'm going to use a different color. They're saying going from x, going all the way around, how much theta is that? Yep. Flash the answer, and there we go. We got it. That's good. I knew we could do that part. Now we have to integrate it. I kind of want to do it, but because it's actually a very simple one. If you note, most of them are just numbers. And then that one cosine guy, I think he'll actually be easy because when you plug it in, it'll be a U sub again. So we'll do that next time. Is that okay? I don't want, yeah, it'll be great for next time. Thanks for hanging out, guys.